Good day everyone and Assalamualaikum warahmatullahi wabarakatuh. I am Hamima M. Abdul Malik, your presenter for today. The topic I will be discussing is about quantum computing. So what is quantum computing? To fully define quantum computing, we need to define some key terms first. So what is quantum? The quantum in quantum computing refers to the quantum mechanics that the system uses to calculate outputs. In physics, a quantum is the smallest possible discrete unit of any physical property. It usually refers to properties of atomic or subatomic particles, such as electrons, neutrons, and photons. So what is a qubit? A qubit is the basic unit of information in quantum computing. Qubits play a similar role in quantum computing as bits play in classical computing, but they behave very differently. How a regular classical computer stores information. A regular computer stores information in a series of zeros and ones. Different kinds of information such as numbers, text, images can be represented this way. Each unit in this series of zeros and ones is called a bit. So a bit can be set to either 0 or 1. A quantum computer does not use bits to store information. Instead, it uses something called qubits. Each qubit can not only be set to 1 or 0, but it can also be set to 1 and 0. So what is quantum computing? Quantum computers harnesses the unique behavior of quantum physics such as superposition, entanglement, quantum interference, and apply it to computing. This introduces new concepts to traditional programming methods. So, superposition. In superposition, quantum particles are a combination of all possible states. They fluctuate until they're observed and measured. One way to picture the difference between binary position and superposition is to imagine a coin. Classical bits are measured by flipping the coin and getting heads or tails. However, if you were able to look at a coin and see both heads and tails at the same time, as well as every state in between, the coin would be in superposition. Entanglement. Entanglement means that quantum components, qubits, photons are connected or entangled, even if they are light years away from each other. By adding and entangling more qubits in a system, quantum computers can calculate exponentially more information and solve more complicated problems. Quantum interference. Quantum interference is the intrinsic behavior of a qubit due to superposition to influence the probability of it collapsing one way or another. Quantum computers are designed and built to reduce interference as much as possible and ensure the most accurate results. To this end, Microsoft uses topological qubits, which are stabilized by manipulating their structure and surrounding them with chemical compounds that protect them from outside interference. Now, at this point, here is the first question. How does quantum computing works? How does quantum computing works? Now, let's move on to the advantages of quantum computers. Faster computations. Quantum computers have computation power higher than supercomputers and normal computers. They can process data at 1,000 times faster than normal computers and supercomputers. Some calculation, if performed by a normal computer, can take 1,000 years, is done by quantum computers in a few seconds. Best for simulation. Quantum computers are best for doing data simulation computing. There are many algorithms created that can simulate various things like weather forecasting, chemical simulation, medicine creation. This type of computers can work better in the medical field. They can detect disease and can create formula for medicines. Different types of disease can be diagnosed and tested in scientific laboratories using these computers. Google search. Quantum computers are used by Google to refine searches. Now, every search on Google can speed up by using these computers. Most relevant results can be populated using quantum computing. High privacy. These computers can make high encryption and is good at cryptography. It is impossible to break the security of quantum computers. Used in radar making. Quantum computing is also used in making radar missiles. The accuracy of radar weapons can be improved by using this technology. Used in artificial intelligence. This type of computers perform well in artificial intelligence. They can make decisions more precisely than normal computers. Scientists can do better research using these computers. The last one, machine learning. Quantum computing is applied nicely by using machine learning techniques. Users can use less code and use machine learning process for improving outcome. And now the disadvantages of quantum computers. The first one is algorithm creation. For every type of computation, it needs to write a new algorithm. Quantum computers cannot work as classical computers. They need special algorithms to perform tasks in their environment. The low temperature needed. As the processing in these computers is done very deeply, so it needs temperature of negative 460 degrees Fahrenheit. This is the lowest temperature of the universe, and it is very difficult to maintain that temperature. Third, not open for public. Due to high range price, they are not available for public use. Also, the errors in this type of computers are high because they are still in the development phase. Number 4, internet security. It is assumed by the scientists that if a quantum computer is implemented in the best way, then whole internet security breaks. This is due to the fact that these computers can decrypt all the codes on the internet. Now, the companies who use quantum computing. Number 1 is Microsoft, IBM, Google, and Honeywell. And the companies who are developing quantum computers include Intel Corporation, IBM Corporation, D-Wave System Corporation, Cambridge Quantum Computing Limited, Lockheed Martin Corporation, and Enion System Incorporated. Now, here is the second question. What do you think is the impact of quantum computers to the society if ever it became accessible and available for the public? Again, what do you think is the impact of computers to the society if ever it became accessible and available for the public? I think that will be all, and thank you.